Nightmare mode detected, recommending soothing music to relieve stress.
Whoa, another nightmare, huh?
Yeah.
Don't worry, we're all good here. Our space journey is going to be fine.
Rest assured, Lei. Asteroid impacts are very, very, very rare. You are safe.
Remember, we have a lot ahead of us. Tigerbot, could you please share the itinerary, please?
Itinerary loading.
Alright, here we go. So, we're going to be exploring asteroids, some of which are your source of anxiety. Then we'll also be checking out space junk and even satellites. Oh, don't forget, we'll be heading to the moon too.
I know. Honestly, I'm really looking forward to better understanding how we can protect our Earth.
Me too.
All right, let's go.
Here's our first stop. We've spotted the 2016 HO3 asteroid.
Oh, there it is. It's a focus of the Tianwen-2 mission.
The 2016 HO3 is also called Kama'olewa. It's a quasi-satellite of the Earth.
So, the big question is, where did this asteroid come from? Was it formed in the early days of the solar system, or was it a fragment from a moon collision? Hey, if Tianwen-2 nails that sample part, we're going to investigate its true origins.
You are right, Tigerbot. You know, this is a complex and challenging mission. It's China's first interplanetary sample return mission. I don't know about you, Yilin, but I want to know how studies in the future can help mankind cope with the risk of asteroids hitting the Earth.
Don't forget, this all requires global collaboration. Folks, this is what you need to know about China's Tianwen-2 mission. This is China's first asteroid flyby and sample return mission. The probe will fly alongside this asteroid, 2016 HO3, conducting detailed observations of its topography, material composition, and other characteristics from a distance of several hundred meters. At an opportune time, it will approach the asteroid to collect surface samples and return them to Earth. Scientists can use these clues to study asteroid formation, evolution, and the patterns of the solar system's evolution. Meanwhile, the Tianwen-2 will continue onward. It will travel to a main belt comet, where it will conduct remote sensing analysis studies. That's pretty a lot.
Lei, do you remember what happened back in 2013? No one saw that asteroid coming until it was already hurtling through Earth's atmosphere.
Yeah, that was a close call. Luckily, it was minor, and the damage was limited.
But no need to panic. Statistically, you're more than 10 times more likely to win the lottery. Twice.
International scientists are closely monitoring what's happening beyond the planet's atmosphere in real time, while using high-tech instruments and cutting-edge analysis. This network of observers is growing to all corners of the world as we speak, and it's made up of a diverse range of experts and scientists. In fact, you two know just the right people that are involved in these joint efforts.
Actually, let's check in with Sun Ye, who is now in one of China's main observatories in Jiangsu province.
Hey, you two up there, if you can see it from above and see the dome, you will know exactly what this place is about. I am right beside the China Near-Earth Object Telescope, also one of the most important night watchers in the International Asteroid Warning Network. Now, for this telescope, its mandate, ever since it's born in 2006, is to find and track asteroids, also to warn their dangers to the globe with its wide and far field of vision. Now we have here Professor Zhao Haibing, who has been working in the field for some 30 years.
那截至目前呢，我们国家总共发现了60多个近地小行，这台望远镜发现了40多个，占据了绝大多数。同时，它贡献了95%以上的这个观测数据，所以它是近天体监测这个领域的功臣。 那我们国家呢，现在其实也在建设这样一个近天体监测网。我们台在西部有个望远镜，已经初步的形成一个网，包括还有我们科学院内的单位那个望远镜以及院外的那个望远镜，能够对近天体这个监测这个事情共同来助力。那这台设备呢是 iOne 组织的这样一个成员望远镜，它就是提供了这个数据。当然，我也希望有更多的望远镜能够来参与这件工作，把近天体的这个早预警、早发现。
Thank you so much, Professor Zhao. Of course, watching out for those dangers is a global relay race and very much a team effort. Now, here we have a list of what D29, that's the handle for this telescope, have filed for the international community in the past years. Perhaps by seeing all of these reports, these piles of entries could reassure us for a little bit. After all, so many people and so many instruments have been working to keep the Earth safe.
It's fascinating how we're building a monitoring system, and it all starts from these observatories.
Yeah, and that system can go global, bringing together partners and industry leaders. Oh, I know just the right person to chat with about this, Dr. Finchtinger from the IEF. Take a bow, please.
Connecting with Dr. Fichtinger.
Hi, Dr. Finchtinger. So nice to connect with you up here in space. We want to hear your thoughts on how the global community can work together in developing and rolling out early warning systems.
We in the International Astronautical Federation are really committed to contribute by fostering the cooperation and the dialogue between all the different stakeholders in order to counteract any risk an asteroid or a near-Earth orbit is posing to the planet and to humankind. We are bringing together all the different stakeholders that can contribute to this effort. It is a global effort, and we are talking about the government sector, the space agencies, industry, of course, research centers, everybody that can contribute. And with bringing together our community, we can contribute to a global effort in case such a danger occurs or such a risk occurs. Important here is efficient monitoring of near-Earth objects, certainly early detection, and then a globally coordinated mitigation strategy. But as I mentioned before, on the other hand, asteroids and near-Earth objects also provide a unique opportunity for scientific research, and they also will contribute to sustainability to life on Earth by providing sources of off-Earth resources. Asteroid mining is a word that is all around. So it's really interesting from two sides.
Thanks so much, Dr. Fichtinger. You know, Yilin, I think a lot of people would worry when hearing all of this, but people do have preventive and protective measures in store.
China can mount a defense. It will implement its first demonstration and verification mission for asteroid defense. The chart says it all. The mission will conduct an ultra-high-speed impact on a near-Earth asteroid, approximately 30 meters in diameter, complete a direct in-orbit assessment of impact effects, and achieve a human in-orbit demonstration and verification of the kinetic impact on near-Earth asteroids. Meanwhile, it will conduct a close-range detection of the target asteroid, study the changes in terrain and landforms caused by the impact, analyze the generation, propagation, and evolution mechanisms of ejecta, reveal the momentum of transfers, and enrich asteroid detection samples. That's a lot.
We are going to have to take it one step at a time. But it's not just asteroids, Yilin. There's actually another threat.
Alert, alert. You are about to enter a space debris zone. Debris traveling at 28,000 kilometers per hour.
Activating avoidance protocols.
Starting orbital maneuver.
Alert cleared. All clear.
Lei, we have to be careful cruising around here. Something as small as a thumbnail hitting the spacecraft would be deadly. When you think about it, our planet, our home, we are all in the same boat. So a lot of these efforts of sorting out space debris and asteroid threats, it comes down to working together, doesn't it?
You are spot on, Yilin, and there are tons of examples of how collaboration has led to better things.
Asteroids may carry clues crucial to understanding the origins of the solar system and other galaxies. They even have the potential to contribute to the sustainability of life on Earth. We are keeping a sharp eye on these space rocks to avoid any surprises. Scientists are compiling and analyzing data from around the world. Networks like the International Asteroid Warning Network are in place to understand, predict, and respond to the potential impact of asteroids on us. And don't forget, China also plans to carry out asteroid defense demonstration mission. Ultimately, studying asteroids is about better protecting and benefiting our lives. We can achieve this through one simple formula: coming together, working hand in hand, and fostering collaboration.
Our space journey is going to be fine.
Don't forget, this all requires global collaboration.
我们有共同的目标。
Maintaining the peaceful uses of outer space.
Possibility, opportunity, fostering the cooperation and the dialogue.
Destination, infinity
And
beyond. Lei, look at these. They're the China-Brazil Earth Resources satellites. You know, the two countries have been collaborating on these satellites since the 1980s.
Wow.
And all the data they gather is crucial for so many fields such as environmental monitoring, disaster management, and urban planning.
Yeah, I actually remember a perfect example of how these satellites were relied on. Back in 2023, Brazil was battered by severe floods. Then the satellites came into action, monitoring the disaster and providing vital information for relief efforts. They've also been instrumental in protecting the Amazon rainforest by monitoring deforestation.
Wow, I think I've got the perfect person to tell us more about this. Let's get him online.
Sure.
Connecting with the president of Brazilian Space Agency. Hi, Ms. Sherman. Thanks for joining us. We've been just checking out the China-Brazil Earth Resources satellites, but we want to know how much more can they do, perhaps on a global scale.
In 2003, I think, yes, in 2003, we had the satellite Cibers B in orbit, was launched in 2003. Just after that, 2004, we opened the catalog of images for free for everybody around the world. And today, more than 1 million images were distributed for many countries around the world. So this started a new movement in space in general, that was the possibility to promote the analysis of images for all countries around the world. And many countries received these images and started to use them in the benefits of their societies. So it was a really great contribution of Brazil and China for the world. If we consider more than China and Brazil in that collaboration, I think we had, both of countries, had the opportunity to promote something very important for the world, I think that our collaboration, Brazil-China, it was one of the most important collaborations, South-South collaboration in the world. It's a very long-term collaboration, more than 35 years now, and we have the opportunity to exchange a lot of knowledge, a little bit of culture too, and I think that the most important part of this collaboration for us here in Brazil was the opportunity to develop our applications for the benefit of our society.
Awesome. Thank you so much, Ms. Shaman.
Yilin, look here, there's another one. It's the first astronomical satellite jointly developed by China and France. It's hunting gamma-ray bursts right now, and it helps scientists decode the origin of the universe.
Starry-eyed collaboration at its finest.
Indeed.
But wait, there's more. Shifting gears to the oceans with the China-France Oceanography Satellite. Blasted off in 2018, this satellite helps us understand ocean dynamics, including winds and waves, and boosts forecasts for tropical storms and storm surges. Plus, it monitors land surfaces, soil moisture, and polar ice caps. So much crucial data delivered on climate change, storms, and sea safety. Together, who knows what we'll uncover next?
Not to brag or anything, but this one here, Yilin, the Mr. Side 2, I was at the launch. It's a project by China and Egypt. Let's check this out. It's a video message from Dr. Sharif Sadki. He's the CEO of the Egyptian Space Agency.
Actually, through our strategic partnership with China, we managed to establish a state-of-the-art assembly integration testing facility, which is considered to be the largest in Africa and the Middle East. So this facility is capable of conducting all the needed tests prior to the launch of the satellites, which includes the simulation of the space environment, simulation of the launching process, and also we have a receiving station, which is a universal receiving station capable of communicating with a very broad range of satellites, in addition to the launching of Mastersat 2. Actually, this was our opportunity to learn and to have capacity building in the field of assembly integration testing and operating satellites through the very successful experience that we have in the launch of Mastersat 2. Brings very strong images that serve very broad sectors of the Sustainable Development Goals like agriculture, urban development, water resources, natural resources.
All right, just keep track of things. Brazil, France, and Egypt, all coming together with China in space.
And there's plenty of room for more countries to join. I think Ms. Holamani can tell us more about that. Ms. Holamani, me and Yilin have been going over a bunch of space cooperation that's happening right now. But how can we be more inclusive, especially for nations with limited resources and developing countries?
Knowing that brilliant minds exist in all countries. There are researchers, there are universities, very sophisticated. The brains are there. The capacity, the infrastructure may not be there, but the intelligence and the capability is there. And I think developing countries, the spacefaring nations, realize that they have a lot to gain, not just to foster greater international collaboration, but also to benefit from different perspectives and different insights from these countries.
Thank you so much, Ms. Holamani. We are heading for the moon now. We're going to talk with you later. See you soon.
We've seen how China teamed up with Brazil, France, and Egypt, enabling their cooperation to benefit all. But that's just the tip of the cosmic iceberg. Data sharing of satellites is a game changer. Think about the 2025 earthquake in Myanmar and the 2022 volcanic eruption in Tonga. China's Gaofen satellites provide critical data to those involved in disaster evaluation and rescue efforts. China's Fengyun meteorological satellites now aid 133 countries and regions by monitoring typhoons, floods, and more. and help prevent potential losses, disasters, and additional destruction from taking place. Satellites can act as superheroes in action.
Our space journey is going to be fine.
Don't forget, this all requires global collaboration.
Maintaining the peaceful uses of outer space.
Possibility,
opportunity, fostering the cooperation and the dialogue.
Destination, infinity
And
beyond.
Spacecraft separated. Destination, the far side of the moon.
Yilin, we're almost there, just approaching the far side of the moon now.
Wow, so this is what the far side looks like.
I think a lot of us still remember the Chang'e 6 mission that took place here. That was incredible when it achieved. And don't forget, Yilin, there was another probe to make it out here, the Chang'e 4. It was the first mission that completed a soft landing on the far side of the moon.
That's right. I could imagine the lunar soil samples collected here could rewrite the history of our solar system. I still remember Chang'e 6 has brought back 1,935.3 gram samples, right, Taikobot?
You have a good memory, Yilin.
Trust me, those samples have the potential to unlock so much information. Since they were brought back to Earth, they've gone through extensive analysis. Honestly, I can't wait to see what we learn.
One study has verified the hypothesis that the moon was entirely covered by a molten magma ocean in the early stages after its birth.
That's critical evidence for understanding the moon's origin and evolution.
Do you know what impresses me most about Chang'e 6 mission?
International collaboration?
You read my mind, Taikobot. Chang'e 6 also carried 4 international payloads from ESA, France, Italy, and Pakistan.
Teamwork makes the dream work.
Hey, that rhymes, Taikobot. I wonder how their research is progressing.
Come on, Yilin, let's catch up with some of our old friends who worked on Chang'e 6 payloads.
Professor Komar, Professor Simon, good to see you again.
Hi, nice to see you all.
It's so nice to see you all again.
So we want to know if there is any latest progress with your scientific payloads.
The reflector is a passive instrument. It has no shutter, no restrictions, so everyone can observe it from lunar orbit. It was observed by NASA, and this data typically go to a planetary data system database, which is then available to all the world after a number of weeks or months it has been taken, processed, and stored online. Chang'e 6 has demonstrated beyond any reasonable doubt that a reflector of that small dimensions, size, and mass can be observed efficiently with a percent success rate about 30%. That the technology we are using specifically for these reflectors gives the good performance that we need, and so we can replicate that. This observation has been carried out the first time on July 31st, 2024, so about a month or two after the landing, and repeated times after that, up to 7 as we currently speak. Exploring the moon, reaching the moon with a rocket, an orbiter, and then landing is very expensive, very difficult. So cooperation is the key. An important efficient space agency is always needed in order to guide the process. And very often some countries provide a rocket, some others provide an orbiter, some others provide a lander, some others provide an instrument. So if we don't put all the efforts together, it will take more time, more money to achieve the final objective.
The satellite is still in the lunar orbit. We have received all the data so it's no more the operational life, but the satellite is still in the lunar orbit, and based on that, it will actually come down within this year on the lunar surface. I must say, actually, the success criteria defined for the IQ Q was the basic was the separation of the successful in that. So that was a big step, and we were really happy that we achieved the first step of that. And then when we got the telemetry and all the system was operational, that was. Really, we were thrilled, and the last one was to take pictures of the. So I mean, our excitement level went going up and up, and is gone up the roof basically when we saw that. You know, the next era is the space era, and we want our young people to be inspired, and it also represented a lot of things. It represented the hard work done by the teams here and in China. There was so much excitement in the whole of country at that time.
I also wonder what future plans we can look forward to.
Now, given the success of this microreflector on Chang'e 6, which has been landed successfully and then observed successfully by another country, then we can build on this and replicate the instrument for Chang'e 7 and Chang'e 8, but also, now that we know that we can observe this reflector with an accuracy down to decimeter, centimeter, millimeter once we get more measurements, but also with the rate of success of attempts, which is around 30%, then we have a pretty good idea of how to use this for a network. So adding Chang'e 7, Chang'e 8, maybe a European mission, a US mission. So this really is the first step of a multi-lander a multi-rover effort for the future, and so the progress that we have been doing is very significant. We have delivered another microreflector. This was a reflector which was in China already since the past. This has been qualified by the Chinese partners, and then we'll proceed with a similar scheme, an old reflector already delivered in China being qualified by them for Chang'e 8.
Yes, actually, that's a very good news that now formally CNSA has selected Pakistan's rover for Chang'e 8. And now, currently, the preliminary design process of the rover is underway, as well as the interface requirement process. What are the requirements of the interface? So work has begun on the rover, and it will be on Chang'e 8 in the 2028 mission. Pakistan is now part of the ILRS, and in ILRS there are so many projects there, and we look forward to those projects. In fact, this indigenous development of the rover is for the purpose that the technologies used will be further used in other ILRS missions, and our teams are looking forward to be part of the ILRS in full strength.
Thanks so much, professors. Take care. Looks like things are heading in the right direction.
Awesome. Okay, Lei, I think we can now head to our final stop, the lunar South Pole.
Let's go.
Now refocusing on a place unknown to mankind, the far side of the moon. Its latest visitor, the Chang'e 6 mission, which brought back lunar samples, a substantial discovery. Using the world's first samples from the moon's far side, Chinese scientists found that the South Pole Aitken Basin, the moon's oldest and largest impact crater, was formed 4.25 billion years ago. This is a critical starting point for understanding the early history of large impacts in our solar system. Another study published in the journal Nature also provided crucial clues for the moon's origin hypothesis and its evolution. With basalt fragments, Chinese researchers have found that the water content in the lunar mantle source region of these basalts is incredibly low, just 1 to 1.5 micrograms per gram, the lowest ever reported. This suggests the mantle on the moon's far side is drier than the near side. This is what we know so far. TaikaBot will keep you updated.
Our space journey is going to be fine.
Don't forget, this all requires global collaboration.
我们有共同的目标。
Maintaining the peaceful uses of outer space.
Possibility,
opportunity, fostering the cooperation and the dialogue.
Destination, infinity
And
beyond.
The temperature at the South Pole could drop to minus 230 degrees Celsius.
Good thing you're in a spaceship.
Lei, you know what's really cool about the South Pole? There are these areas called permanently shadowed regions that never see the light of day. And it's precisely in those parts that there may be water ice. Imagine what it would mean for future space explorers.
Basically the equivalent of a space convenience store.
That would be an absolute game changer. It's a major objective of the Chang'e 7 mission. It will search for water ice and carry out a series of scientific explorations to deepen the understanding of the lunar South Pole.
Looks like this place will really be in the limelight in the years to come.
And don't forget, the Chang'e 8 probe will carry out experiments on lunar resource utilization in its vicinity, and along with the Chang'e 7, they will constitute the basic model of the Lunar Research Station.
Chang'e 7 and Chang'e 8. The dynamic duo of lunar exploration.
We can see them as the prototypes of our future lunar bases. Lei, I know the person to learn a lot more about this endeavor. China's Lunar Exploration Program Chief Designer, Mr. Wu Weiren.
Chief designer is online.
你好，吴院士，
吴磊、一林，你们好。
你能给我们介绍一下国际月球科研站最新的进展吗？它的目标是什么呢？
我们希望能够在探月4期建设的基础上，能够由中国发起，多个国家参与这么一个国际大科研工程。目前进展还是很顺利的。它主要是在月球南极建设一个月球科研站，这个科研站呢，能够能源自动供给，是吧？通信能够就地实现，以月球南极为中心，然后由月面和月球轨道这么组成，可以向更远的地方辐射。比如说，我们有月球探测车、月球着陆器、月球飞跃器，以及我们构建的网络，这多个系统组成。组成以后啊，我们能够在上面长时间的无人探测，也可以实现短时间的有人参与，这么一个能源供给充分、通信设施齐备，然后各种实验设施具备，能够长时间的多领域的这种科学探测。比如说，我们对月球资源、月球的那个起源，以及月球上以月球为基础的这种夜基天文观测，以及以月球为重要的这个指针点，我们向地球是吧进行延伸，一系列科学探测和技术实验的任务。当然，最终我认为，我们月球科研的建设要为将来奔向火星服务，为奔向火星进行一系列技术实验和科学验证，最后为它奠定基础。我认为这是我们很重要的目标。
吴院士，国际月球科研站目前会有哪些合作计划？
我们觉得呢，现在在国际月球科研站上要实现多个国家参与，或者多个国际组织参与。按照我们目前的建议或者我们的设想，我们希望能够实现50个国家，500个国际科研机构或者组织，再就是能够有5000名国际科学家一起共同参与。所以把它简单归纳说实现3个5这么一个目标。我觉得以后我们就可以全世界科学家都可以在这个月球科研站和我们地面是吧国际合作总部一起，我们共同分享我们的探月的成果，共同为我们奔向火星做技术准备。
吴院士，那能否详细讲讲它将如何开展国际合作呢？
目前呢，我们认为主要是这么几个方面。第一，在技术层面， 技术层面是什么？我们一定要共同参与，共同来制定方案。然后呢，在技术的实现上，首先要那个技术有所突破，要实现上，比如月球南极这种恶劣的环境，光照什么那个能源的供给以及它的高低温等等这些环境上，我们要一起要突破它。另外，技术实现了它在体现在地面，就是地面对它的测量、控制、通信这方面，比如说我们和欧洲航天局，我们和那个南美洲，比如阿根廷这样一些国家，以及我们以后还会有一些新兴的这么一些国家，我们希望他们共同参与。第二个就是在科学仪器的合作，我们到月亮上干什么呢？这主要体现在科学仪器探测方面。这些仪器载荷方面啊，我们希望多个国家都能够参与。有些我们可以合作，有的呢我们可以和他们一起来共同研究。还有呢，这些国家可以自己独立研制，我们帮他送上去。第三个方面啊，就是一些科学数据。这个科学数据探测了过后啊，我们共同研究，或者分发给这些参与的国家一起来共同研究。最后我们得出一些世界性的、首次性的这种科学的一些结论，是吧？这科学技术突破是我们探测月球最重要的目的。那么第四个方面呢，我觉得我们一起在地面这个总部，是吧？这个总部设在中国，那么欢迎全世界的科学家都在总部里面一起，我们共同交流，有共同的目标，而且呢有共同的这种意志，最后我们一起取得世界性的成果。
好的，吴院士，非常感谢，再见。And I didn't forget, we still have Miss Hola Many connected with us.
The director of the United Nations Office for Outer Space Affairs is back online.
Hey, Miss Hola Many, what's your take on this International Lunar Research Station?
So UNUSA is really to foster greater international collaboration in the spirit of maintaining the peaceful uses of outer space. What I've seen from my engagement with China, from the Chinese 6 mission, is a very open attitude from China. We saw, I think it was 4 international payloads which were launched on Chinese 6 from different countries, and also the results, the samples that came from that mission have been shared with researchers around the world. So this is the kind of collaborative, open spirit that we really welcome and foster. I really hope that it will not just be an initiative of 1 or 2 countries, but that many more countries will participate. At the end of the day, space and the exploration of space is meant to be, according to the Outer Space Treaty, for the benefit of all humankind. And there is a lot of desire from many member states to really support their national space economies by being part of these initiatives. And I hope that by being the concrete projects on the one hand and the dialogue in the diplomatic forum on the other, that we will converge and see really positive results. China is doing what it can to invite collaboration and cooperation in this spirit, and I hope that it will bear fruit.
That's great to hear. Ms. Holameni, thanks so much for your insights. Bye.
International cooperation, key to unlocking the universe.
You are spot on, TechnoBot. So what big moves is China planning?
Processing the latest on China's space adventures. According to the China National Space Administration, there are 4 key areas of focus. First, boosting space access capabilities. Think bigger, more powerful heavy lift launch vehicles and reusable space transportation systems. Don't forget, efficiency and green tech are paramount for breakthroughs in future space launches. Second, speeding up space exploration. Lunar missions like the Chang'e 7 and the Chang'e 8 are on the fast track, alongside building the International Lunar Research Station. Plus, planetary projects are on. The Tianwen 3 aims for Mars sample returns, while the Tianwen 4 is for Jupiter system exploration. These ambitious goals are all in the works. There will even be more probing for gravitational waves in space. talk about reaching for the stars. Third, they're expanding space applications by building a next-gen civilian space infrastructure and developing a satellite internet system. And, finally, they're promoting safe commercial spaceflight with a new action plan. So much to look forward to. Having witnessed remarkable collaboration between China and a multitude of partners, and expect that to continue, the Tianwen-3 mission is welcoming international partners to actively participate in the mission and jointly explore Mars's mysteries. The Chang'e 5 lunar samples have been distributed to international scientists. The Chang'e 7 and the Chang'e 8 missions have both unveiled their international cooperation projects. That includes working together at the International Lunar Research Station, in the Space Information Corridor, under the Belt and Road Initiative, throughout the construction and application of the BRICS remote sensing satellite constellation, and beyond. It's all for protecting Earth, improving people's livelihoods, and serving human civilization. In other words, it's space for all.
What a journey, Lei! From exploring asteroids and satellites to learning about the moon's history and future.
Yeah, and so much of this is being done in an inclusive and open manner. Think of all the countries and experts coming together.
I think this is my favorite part. People working together for common advancements. It's like everyone's in it together.
Absolutely love it. I can't wait for more. All right, how shall we move forward?
Agreed. Our journey doesn't end here, right, Taikobot?
Oh yes, I'm ready.
Initiating blast off. Destination: infinity
and beyond.
Awesome! Thank you so much, Mr. Chairman.
I don't know about you, Yilin.
And beyond.
Thanks, Stinger. You know, Yilin, I know a lot of people with what 从艺术的角度，当然我是以及逻辑和效果。
Ready?
Go! Wow, look at this AI-powered humanoid robot.
His name is Taikobot, and he's actually role-played by our colleague.